to whatever hardware platform you're on that, you know, are the difference between x86 and ARM and Power and mainframe and, you know, Mac M1 chips or whatever. So we'll talk through this. This is actually slides taken from 3 or 4 different pieces. I tried to cut out as much of the marketing hype as possible and have some good technical updates. One of the things, though, that I will say about mainframes is that they're very heavy on security, and, you know, we're all seeing more data breaches. You know, quite a bit of data in the world is not encrypted, although I think server data is encrypted more than other places. And yet I've seen surveys where mobile smartphones have a higher percentage of encrypted data than what computer servers do in data centers, which is interesting. And so I won't dwell on this anymore. But these are 3 themes that you'll see out of LinuxOne Z. And in fact, I would tell you that LinuxOne Power would be very similar in many ways in their mind. But, you know, to really focus on the security, the encryption, the privacy of the mainframe, it truly, you know, in fact, I'm having conversations with clients about it being the enterprise cloud data server. Regardless of where your apps are at, you know, it can handle APIs, it runs OpenShift and Kubernetes, it you know, runs RHEL and SLES and Ubuntu Linux, it runs KVM, and so it truly can be a cloud native environment if you want.
Hey.
And then, you know, and the new,
because I'm trying to help Sam.
I think somebody need to go on mute.
And in
Lee, mute yourself. He is now. He's muted.
Okay. I wanted to make sure I wasn't speaking over somebody who had a question, but and in the next generation of apps and data, okay, there are 2 models of mainframes and hence mainframe computers. There is a single rack machine. These are 19-inch racks. They fit on 2 floor tiles. So they fit beautifully in cloud data centers right along in the middle of a rack of distributed gear. And so they truly are a distributed server. This one, we'll have specs in a minute. The big one, which these are the big mainframes that run banks and airlines and government agencies, they can go out to 4 frames. You know, we believe that in many cases there's a lower total cost of ownership than x86 because I can take several cores of Intel, you know, cores running a software app and run it on a single core of a mainframe. We call them IFLs. And so if I'm paying by the core for software, you know, I may pay more for hardware and less for software, and I can end up saving money. And obviously you do each one, you do it, you know, what's right for that business, for that workload. Here's some specs on the machines. So this single frame can run 65 Linux cores. You'll note these are very high clock speeds. I believe 5.2 is the fastest gigahertz processor, commercial processor in the industry. Power systems have had very high clock speeds up around 5 as well. You'll see that this frame can go to 16 terabytes of memory. These can go up to 40 terabytes of memory. You know, we use partitions, and then we can run virtual guest or run Kubernetes OpenShift clusters inside partitions. And you can see that I can put a lot of memory in a single LPAR. These secure enclaves and the HyperProtect virtual servers, we'll talk about in a bit. We'll talk a little bit about the trusted execution environment. We're actually using PDUs, you know, because it's a 19-inch rack, similar to what you'll see with racks, of Intel servers. What's interesting is none of these require water, external water, although you can use it, but they actually are water-cooled machines with a closed system that the water is air-cooled by the mainframe, but the water is what actually cools the processors and all of that, where this is purely an air-cooled machine. This does not require raised floor. And I'm not sure if these do, but I know this one can run just on a slab of concrete if you wanted it to. They will do, both either bottom exit or top exit for networking, I/O, power. You can put SSDs in a card that then goes in a slot on the PCI bus. And this one's kind of interesting. It has 8U of space in here that you can actually put in things like network switches or flash storage or things like that. And you can actually have a fully hyperconverged system with disk networking and processing memory in the same 19-inch frame. So that's kind of a unique piece of that. HyperProtect servers are kind of cool. And there's something that...
Can I ask a question on that last slide?
Yeah, I'll go back. Go ahead.
So the nomenclature, LT1 versus LT2, it almost looks like the LT2, is it just something built to be more economical, or is it that additional reserve space for storage, or what's the distinction between LT1 and LT2? Good
question. So the LT1, you can go from one processor up to 190 processors, and just by adding more frames, and the processors come in drawers, and there'll be like 65. I think this 65 cores is actually 2 drawers that has the processing CPUs, the memory DIMMs, and the I/O buses. And then there's other drawers that have networking adapters, or, PCI adapters, and they fit in drawers that are in there. And so the LT1 is like the full size big mainframe. We used to call these like business class, or like a mid-range system. If these were classic mainframe systems, this thing would be able to go up to like 6 mainframe engines, as I call them. Today, I think it can go close to 10,000 MIPS. This guy up here, if this was a mainframe, could probably go to 160 or 70,000 MIPS. And so these are expandable, and you can grow by adding frames to the box, where this is always going to be a single frame. It is at a lower price point. And in fact, there's a lot of, say, mid-size insurance companies that this would be enough mainframe to run the entire business. If you're a big bank, you're in these 3 and 4 frame systems, depending on how much I/O and you need, because that's usually what you scale out, is because you have tons and tons of disk and tape adapters in there. What's interesting is this doesn't use like top of rack switches and end of row switches. You normally plug these into the backbone data center network, but a processor, something here that might have, say, 100 cores might only need like 4 adapters into the backbone, and that's all the networking complexity and infrastructure and cost. Those are obviously much more expensive ports than a top of rack switch, but most of the networking is software defined in the machine, and so it's one of the benefits of that. But that's the difference between LT1 and 2.
Can I ask a question?
Good question.
Great, thank you.
Yeah, please do.
Is the
You bet.
LT2, that's a 19-inch rack?
All of these are 19-inch racks. So this is like 2 19-inch racks.
Okay. I thought
Yes.
I thought the water cooled were going to be the old-fashioned rack size.
Yeah, they used to be 24-inch custom racks.
Yeah.
And we knew, so there are, and we'll talk a little bit about this, there are security services in the IBM cloud that are actually running on one of these LinuxOne systems for the x86 workloads or the power workloads that run in the IBM cloud. And so to make this cloud data center friendly, it needed to get to a 19-inch rack. So all of these are 19-inch racks, and that's something that is fairly new in the last couple of years.
Thank you.
They use PCI 4 buses. Yeah, you're welcome. I mean, it's much more industry standard design than the mainframes of the past. And the enterprise power systems are doing the same thing. So a HyperProtect virtual server, and you can do this in the IBM cloud, you can do it on premises. It allows you to sign images that, like, if you have a Linux kernel, when it's booting, it will compare, the signature that that code is presenting to something that was saved in the, I'm not sure of exactly how that worked, but it checks it out and to make sure that it hasn't been tampered with from when that was created and signed and certified. So, that's the idea of, you can do that with apps, you can do it with the Linux kernel. When you deploy these, you can have a DevSecOps pipeline to be very clear of what's getting pushed into the machine. What's nice is, if you're running in one of these, you have no root access at all. IBM can't get to it, while it's running. We send you a bundle that's like a software appliance that says, here's the bundle. It has, the Linux kernel, the hypervisor, the software-defined networking and all that. And then you can take and just deploy virtual servers, like a VMware guest or a ZVM guest, or, whatever you want to call it, KVM virtual machine. And you have REST access into them, but you do not have root access, and you cannot get in and work with, Linux things and copy files off. The data is encrypted automatically at rest and in flight. And so the idea is that these are highly locked down environments that are, impossible is a really strong word, but if you set it up right, it ought to be close to impossible or impossible for a bad actor to get in there and see data, alter the code, steal the data, and so forth. And it's using capabilities built in the machine. Yes, question.
How do they handle maintenance? I mean, with so many servers running on one of these boxes, how do they schedule and handle maintenance? Or can they shut part of the box down and keep it running, or does it stay up? How long does it take if you have to take the whole thing down, how long does it take to get the whole thing back up again? Stuff like that.
Good question. So
yeah, maintenance.
I'll start with this and then keep asking me questions as you have, if I haven't answered all. If the machine is powered down,
okay,
that power up sequence, I believe, is 15 to 20 minutes for the entire box. And then I'll have an LPAR to a state where I can start to boot an operating system. Okay. So it's the
first
and then I could take an LPAR and I would boot an operating system image. That might be one of these HyperProtect virtual servers. If it's ZOS, it's 15 to 20 minutes or more to come up. I think Linux comes up a lot faster in that regard. And so if you have to do a kernel update of the Linux kernel, since this is a software bundle appliance that you just get this blob from IBM that you load it and boot it. And in there is all of the when you need to update the Linux kernel, or you have security patches or things, that's IBM's responsibility to ship that to the client, or to, make it available. Client can download it and install it. And so all the other HyperProtect virtual servers could be up while I'm recycling one of them. The machine, it's very seldom that I have to do what I call a power on reset, where I take the whole machine down. Clients will take and have planned windows where they will take down an LPAR. There are clients that do that once a year. I have clients that do it every month. And I would think that as often as you would feel the need to reboot Linux, you would probably do that on this machine if you're not doing it for things like, anything hardware related. If you have Linux code that has a memory leak, a mainframe won't stop a memory leak any more than any other machine, and you would reboot that. Mm-hmm. But it should be a very similar time, because if you're running RHEL or SUSE or something, in this case, the Linux kernel is going to be very similar. And if anything, you're on faster processors and things here, and it shouldn't be slower than what you see on an x86 machine. But I will admit I've never done a side-by-side comparison. And yet a lot of this is designed to be, you keep the machine up, you try to keep workloads up, but Linux does need to come down and restart to pick up kernel changes. Many of the security changes, you can do dynamically if you're patching certain things. That's a great question.
Well, I can remember lots of Sunday nights from like midnight to 3 o'clock in the morning. That was a maintenance window, and that's when
it was. and they're no longer a client of mine, and again, I will protect the company's name because I'm not allowed to share it, but you would know who this is. And in fact, they have some St. Louis roots, but they recycle their mainframes once a year at the fall time change when they have to fall back an hour. And there's no graceful way to do that with 30-year-old apps, you know? And so they shut down at 2 a.m. They wait for the clock to catch up to 2 a.m. and they come up, but that is their once a year maintenance window. And it's the only time because they've got to keep those apps that are running in that mainframe up and running all the time because they truly run a core part of that company. And you're right, it is a lot different than it used to be. And I think that Linux has done this. I know AIX has done this, ZOS has done this, IBM has done this, where we try to make it more dynamic. But there are times you got to reboot, you know. So, you know, and you'll have places you can read about this, but the idea is to try to really make this that these are very safe environments for highly secure applications or data to make it far harder to get at, and yet it's running Linux, and so it's kind of a cool thing.
So what is that company going to do when we go on universal daylight time and they don't gain their hour every year?
I know. Well, I guess they'll have to take an outage once a year, you know. But that's a good question, you know, and I know there are people pushing for that.
Well,
go ahead.
You may be covering this later, but I was led to understand that, and maybe the Linux one doesn't, but if you use regular ZVM in Linux, it does, that you could cluster these things. So if you need to do like hardware maintenance or something on the box, you could move the application live over to another system.
Yes.
And the system would stay up. I mean, the application system would stay up.
Yeah, and in fact, you're right. Now, ZVM does that better than KVM, and ZVM is an old mainframe operating system that has been reborn as a world-class hypervisor. And so they call it single system image, where I can have multiple LPARs on the same machine or different machines, and I can move workloads live. It's called live guest relocation. And like in AIX, it's called, or in Power VM, it's called live partition mobility. It's called vMotion, you know, in VMware. And so, yes, that does exist. And I can keep workloads up, you know, then play with that code. And, you know, the issue is that when I move it, I'm moving that image of Linux with its patches and all that. And when I move it back, I'm still doing that. So, but I could go into that, I could make changes and do things and then reboot, you know, have apps come up. And so it depends on what type of maintenance I'm doing. But that's a place where all these virtualized servers have come so far in the last 10, 15 years. And ZVM does that.
Is ZVM, is that the ancestor of old VM?
Yeah, the old VM is now called ZVM, just like the old MVS was OS 390 and now ZOS.
Okay.
And what's interesting is if you know VMware, they talk about the software-defined data center. Everything in ZVM is software-defined. The processors, the memory, the storage, the networking, and you can automate all of it, and it is a fully software-defined environment and very modern. It uses some old clunky terms like punch and things that, you know, from its heritage. And it isn't like there's 1,000 universities teaching ZVM, but you can run you can run Linux servers on the mainframe at 90% busy. You know, you would not dare run Linux at that busy on really any other hardware that I'm heard of. Power will guarantee you can. I know you can run at least AIX at 80% busy on the enterprise power systems. I think Linux has that too, and it's an in-writing type guarantee that Power makes that's really cool. But you know, you get Intel systems up 50, 60%, and they can really start to struggle with sustained, you know, performance. They can certainly peak into that and peak higher. So just real quick here, HyperProtect digital assets is like blockchain, and the IBM Cloud blockchain and digital asset offerings runs on a mainframe. Data privacy passports could be a whole session. It's really interesting. You take any data object that you can get to via JDBC. So it can be SQL Server, Oracle, DB2 on the mainframe. There's other things. You put metadata around it and you put security policies around it. So when that object leaves its server or its home, goes to the cloud, goes to a client, goes to a data lake, I can still say, okay, who are you? And I give you, in essence, a passport. And you say, I'm Bill, and I want to look at this data object. You send the passport back to a mainframe passport controller, and it says, okay, yep, you're Bill, and you get to see the first 4 columns, but we're going to encrypt everything else because you're not allowed to see that data. If you're the data owner, you see everything. So there's some really cool data privacy things that the mainframe does. There are ways that you can partition and isolate workloads. LPAR technology in the mainframe, if you have things that are LPAR, separate LPARs with no sharing of I/O and devices and all that, it is exactly the same from the government's perspective as air-gapped systems. We've talked about secure application pipelines. So these are some of the workloads that run in a HyperProtect virtual server, and they do some nice things. This is a big it depends. I have seen, since I can run up to 60, cores in an LT1 machine, that can go 190 cores. I can literally do hundreds of cores if I get even 6-to-1, 8-to-1 consolidation. When IBMers tell you you can do 20-to-1, 30-to-1 Intel to IFLs, that's if that Intel core is not virtualized and running at 5-7% busy, you might. But, most Intel servers are virtualized today. And so, I hate some of these numbers. I will say that and granted it says up to, I have seen cases where you can save significant money, especially if you have commercial software and you're paying by the core. Now, like Oracle will say a mainframe core is twice the licenses of an x86 core. But if you use 6 times less core, you're going to save money on Oracle. So, everybody has to do the math. And so, let the buyer do their homework, and that's not a promise. This is interesting. MongoDB, we have done benchmarking where we will scale big, but we will not shard the database, which is what is a common technique in Mongo to scale. And so you get really fast performance, and you would expect big machines, whether Power Z, to be, low latency. But that I can put a single database in that shard is kind of a cool thing for large MongoDB workloads. In some sense, it's like, I don't care if it's 6.6 versus 5.8 or whatever, but as you would expect, you can run more containers on, and this is the smaller Linux system than an x86 system. And yet, x86 systems can have 36 cores in some of them. Some of them are, more in the 16 to 24 range. And it is one of the things why people buy and put Linux on a mainframe is that they can consolidate and save money. So these are some of the reference charts that I don't want to go through. Z15 is the current mainframe, and then if you're buying the Linux-only mainframe, it's the LinuxOne 3. These are like LinuxOne 2s. These are Linux 1s. And then you see that, and this is like the 15th generation of CMOS mainframe. That's the 14, 13, 12. Here's 13. This is 12. They got fancy here, and this is 11. This is 10. This is 9. You can see the common distros for Linux. Here's a website link you can go to for more details. So these are the 3 main ones. And granted, most commercial customers today, it really in the US is only Red Hat. They've won that battle. Here's some more details of kernel levels, between different versions of SLES, of Red Hat, and there's links here. You'll see Ubuntu. So I'll leave these to the reader to look at. OpenShift runs on the mainframe. It runs on Power. Runs on x86. It runs on-prem in the cloud. And this is the same RHEL, CoreOS, the same Kubernetes and OpenShift that on any of these platforms, and this including anybody's x86 servers, obviously the chip architecture of a mainframe is different than Power, is different than x86, is different than ARM. And so if I have a JBoss, you know, app server, WebSphere Liberty server, MongoDB server, I have to compile it in the chip architecture of that chip I want to run it on. A lot of the open source tools and the commercial software Linux providers, you know, offer Linux on Power, Linux on Z, Linux on Intel. Some do not. If you're writing and compiling your own, you certainly have all the compilers. You can do compilation. And what is nice is Kubernetes, you tell it the platform. If you have a multi-platform container that has the binaries, say, for Intel, Power, and Z, when you deploy it and you're telling it PPC64, S390, you know, X64, Kubernetes knows which version of the multi-platform container to take and push to that server node. And so you can have the ability, you know, to deploy out of the same push, say, coming Git to Jenkins into servers in Kubernetes. You know, you can have an app that would say deploy an app server on Intel and a database server on the mainframe if you wanted. And it ships the same day across Z and Power and x86 from Red Hat. You know, we're on 4.7 of OpenShift now. That's been a nice story. And it truly gives you choice where I can take containers and run them in Amazon and Google and Azure and the IBM Cloud and on-prem. So that is a big part of the mainframe story today. And RHEL, you know, is kind of the same thing. And of course, since IBM bought RHEL, you know, we talk a lot more about it than we used to. And yet they really are running in many ways as a separate company. You know, here's a typical Red Hat OpenShift container platform. That's RHOCP cluster of control nodes and compute nodes or worker nodes. You know, here's ZVM or KVM as a hypervisor running in an LPAR. I can have multiple clusters, you know, running in an LPAR. And, you know, there's like free 30-day, I think, trials that you can download OpenShift and run it yourself. Here's some installation material on ZVM. And it does require ZVM today. KVM is supposed to be coming in the future for the mainframe. And then IBM has these things called cloud packs that if you're around IBM software much, most people talk about this. This is not so much true for AIX, for ZOS, or IBM I, but on the x86 platform, you know, anything that is Linux anywhere, this is what IBM will talk about. So it is OpenShift at the bottom. It's some IBM value-added things for management and monitoring, and then it's containerized software. So you can buy DB2 in a OpenShift container. You can buy MQ and WebSphere and things like that. There's something that Red Hat calls code-ready workspaces, which is kind of their DevOps, you know, IDE environment. That is actually runs as an OpenShift container, and it works on Z. So, you know, without going in depth here, because this, again, is a whole session on its own, these were the cloud packs in 2020. They did some changes to 2021, and in both cases, not every component of, say, Cloud Pak for Data is on Linux on Z, even though it is on Linux on Intel. And Linux on Power is kind of the same way. Many of them are there. They're not all full-featured, and in fact, like Cloud Pak for Security is not even really available yet running on Z, but certainly Z can work and send data to a Cloud Pak for Security server running in Kubernetes and OpenShift somewhere else. So, you know, this is a reference chart, but, you know, if you hear IBM talk about Cloud Paks, this at least shows you today, you know, what they are. And let me check something here. This is slide 19. I'm going to go back up to the title page for a minute. Here's my email address. You're welcome to reach out to me. If I don't know your name, why don't you put, like, you know, the SLUG or SLUG, whatever you call yourselves, your acronym. I'll know it's from tonight, and I'll be glad to respond when I can and send you a URL or something like that. So that's Cloud Paks, and that is a lot in addition to just standard open source software, commercial software that runs on Linux. Oracle it runs like a champ on Linux on Z. Because it scales vertically, and you know, databases like to scale vertically as well as horizontally. That's actually the biggest commercial workload on the mainframe for Linux is Oracle database. So moving on to some of the fun stuff in the hardware. New in the Z15 chip, there are instructions that do vector math, which is important for accelerating AI. You can do Java search strings. The vector math says, and I can take and do matrix math where I do a whole bunch of operations, but in one cycle versus, 20 operations in 20 cycles. Significantly speeds up searching in strings and so forth. Yeah, go ahead.
Talking about these vector instructions, does that bear any resemblance to the old Cray vector instructions?
In some ways it does. And in fact, the old mainframes had a vector like bolt-on processor too, and then they went away.
Actually,
but yeah, it's that idea.
Actually, they called it the vector facility. And
that's right. I couldn't remember the name because it's been long. Go ahead.
It was actually instruction set extension. So when they were executing, the regular ops didn't execute. And I partially know this because I worked as a VM system programmer in New York back then. And one of our local engineers was a developer in Poughkeepsie. And when they did cuts, he went to the field service. But he worked on designing it. So
here's two. Go ahead.
I was also going to say Intel does that because the Intel chip has the vector instructions also.
Yeah. And this is like the second generation vector set of instructions in the chip. Somebody else want to say something?
No, I used to work for Cray back in the late 80s, and the vector instructions, we used them mostly for matrix math, but they could produce a full floating point result of the vector math every clock cycle. Another result.
Amazing, isn't it?
It took a while to get it going. It took a number of clock cycles before the first answer showed up, but after that, one would pop out at every single clock cycle. Yeah. And it was pretty impressive for the day.
Yeah, they were. And they were a cool looking machine, but they were really impressive for what they excelled at.
They were great to sleep on too.
Oh, I can imagine.
Yeah,
deep
put you right to sleep.
I bet. Deep learning and machine learning algorithms, this is one of the things that really helps them do what they do. Granted, they like GPUs and things, but this is something that is an enhancement, and so Linux supports that. There's always been hardware compression hardware in the mainframe, but there's new, gzip Huffman type compression, and you'll see that in some cases, and I'll talk about this in a minute. Like I can do it 42 times faster in the compression hardware that is on the chip on the mainframe versus software compression. It turns out I had to do some homework of what did they mean by E. coli. I figured this was a text of the Bible and so forth. So here's some explanations, but there's something called the Canterbury corpus, which is a standard set of files that are used for benchmarking compression, capabilities.
Oh, I remember benchmarking.
Yeah, and so, the worst software compression example versus using this integrated accelerator. This used to be on an adapter card, and so you had to go out over the PCI bus to get to the compression hardware. Now it's right on the chip. But you can see some nice times, and of course, if I can compress the data, then if I'm encrypting, it's less data to encrypt, it's less data to go over the network, it's less data on disk. Java loves the use of this. So just again, interesting. And this chart came from Share. So this is like Ubuntu 1910. This is Red Hat 8.1. Here's SLES 12 SP5, and it can run in an LPAR. So that's, if you see these, that's what those are for. And I took this from a recent Share presentation. The CPAC-F is the encryption coprocessor on every core. It has the ability now to in mass, in real time, encrypt data going to disk. And so it's encrypted before it leaves the mainframe, whether it's Linux or ZOS. almost no CPU overhead, and I've seen this personally, so this isn't just me reading chartware. This is real life experience. We had a client encrypt all of their DB2 data, and it's a company, again, you guys are probably customers of, some of you, and you would know who it is, 1 month, and their entire production DB2 database of, I don't know how many, how much disk, but it's a lot, was encrypted by about 4 or 5 people working pretty hard that month. But elliptic curve cryptography is used more and more for TLS protocols and things. And so you see these really big hardware boosts that you might expect from hardware versus software. Oh, yeah. And so you can compress and encrypt, and you can just do this without database changes, without application changes, because it's down in the operating system, in the IO part of it. It works beautifully, and it is a big part, so now there's no reason not to have your data encrypted. And there's like DMCrypt, and there's I forget the other file, but there are encrypted file systems in Linux that support this, and so all of this works with Linux environments. Here's this idea of a secure boot where, again, you have signed code, from trusted sources. It's checking, in firmware and so forth to make sure that it has not been disabled or changed and that it's coming from a trusted source, starting with the 5.3 kernel. I'll let you read more about that. Here's that the SSD or NVMe drive. So here's the carrier card that goes in a PCI slot. And then this is like an Intel disk or a Samsung disk. There's certain ones that have been tested by IBM and verified. And so you can add SSD storage, NVMe storage into the mainframe, that is persistent storage. And obviously, I've heard it called memory class or storage class memory. So it's not memory speeds, but it's a whole lot faster than going to disk. No cabling. And so this is really catching on in general, and now mainframes have the ability to work with that. This is a really cool technology, shared memory controllers, and D for direct and R for remote. And the idea is that instead of going through the entire TCP/IP stack, to go from peer to peer, I have very high speed direct connections. It has to be within, reasonable distance if it's remote. We added the capability now that the peers can be on different subnets. But if you've heard of something in the mainframe called a hypersocket, which is an in-memory point-to-point network that allows me to do LPAR to LPAR communications blindingly fast, but on CPU cost. So you use it wisely on ZOS. Here, the Linux engines are a fraction of the cost. Even though it's the same hardware, IBM sells Linux-only processors at a small fraction of the cost of a mainframe general-purpose engine or general-purpose processor. But this is some really cool stuff, and if you like networking, it's worth doing some reading about SMCD. SMCR uses something called a Rocky card. These are on power systems as well. It's remote. Remote memory access over converged Ethernet. That is or remote direct memory access over converged Ethernet. That's Rocky. So those are adapter cards. There are ways to have these shared in a group. They also have to have standard, we call them OS adapters. Those are our NICs for TCP/IP communication. And here's some, tools and code that help you set this up. But this allows for even system to system extremely high speed communications compared to what you could ever get with TCP/IP, going over even a backbone network. Here's a little bit more about that. This is part of the HyperProtect virtual servers, in that, today, if I had a hacker that got in and got root access, he could come into, a VM running under KVM virtualization or Linux virtualization and alter the memory. If someone got into KVM, they could actually work with the guest and work with, the state of the guest. Prism is the hardware firmware that really controls the hardware sharing and virtualization of processors and memory and adapters. And this is not a place you want to be having somebody messing around. but the secure execution, is able to protect the memory, the state with what they call an ultravisor. And so these attacks would all be rejected and not possible. And so you can put, data in here and know that it's, again, impossible to hack is a very strong word, and I'm not going to say that, but they are far more protected than standard KVM guest running in a machine. And so you can see there's a lot of all these slides I've been talking about since this black slide are all hardware innovations in the latest mainframe and the latest LinuxOne server. So because of time, I'm not going to read this. I'll let you read this, but there's some really cool stuff that's here. One reference story, and you can find this out on the web. This is a public story. This is the National Weather Bureau of the UK, the Met Office. And they did a migration years ago from x86 to a couple of LinuxOne mainframes. They've been very happy with it. And there are references out there, and I'm not here to sell you about this, so I'll leave that to the reader to talk about. What's cool is there's a LinuxOne community cloud where you can get no-cost access to Linux-based Linux servers running on a mainframe. You can work with OpenShift. You can try software. We use it for our Master the Mainframe contest and other academic uses. It's hosted up in Marist College in Poughkeepsie, New York, home of the mainframe. It is a LinuxOne 3 system today running ZVM. Here's that SSI cluster, that allows you to move workloads live. Now, you guys can't do that, but the managers can do that to keep guests up while they're doing maintenance and so forth. OpenShift is added. Here's here's some things. Don't I have I have it later. So now I'm almost done here, but here are websites that you can go read about and look at to learn more about KVM on Z, Linux on Z. Developers are on there, in-depth technical articles. Here's the documentation that's out there, webcast. There's all kinds of things for learning, more blogs. The LinuxOne Community Cloud, you can access it on this link and sign up. You need an IBM ID, but there's no cost for that anybody can get one. More papers to read, things if you want. Certainly you can, if you work, you can talk to your IBM business partner representative and get, workshops and so forth. And so that's the end of my story, the obligatory copyright notices and all that. But I've really enjoyed putting this together and chatting. I'll be glad to take more questions, but this is a good high-level introduction to where Linux is at on the mainframe. It will never replace x86, but there are some things because of the hardware and the security and things and consolidation that this does that is really, really good. And so thank you for your time and attention. And any other questions before I hand this back?
I have a general question for you.
Yeah.
As a side thing, do you know about the VM workshop?
I am aware of different workshops for VM, for ZOS.
This is for ZVM.
This is for ZVM, and I think it's like a 5-day no-cost workshop where you get labs and technical training. Is that the one that you're thinking of?
No, that one's probably run by IBM. I'd be interested in learning about it. But this one used to be out there forever. Back when the option was things like Share or IBM conferences, it was held at universities, and it would come, you could rent a room in a dorm, and IBM and other people would give talks. So it was, and they resurrected it, and they're trying to see if they can do it in person this year. Last year they did it virtually, and it's
there are more of those than I can keep up with. I will admit that, but I know the person who runs all of the what I call the academic initiative work for the mainframe, and that's working both with.
This was not academic.
This can be for clients, right? This can be education for clients that have like young, system progs, and they need to learn. So it isn't just for college students and so forth. But
well, this was more held at universities because a lot of the VM systems programmers worked at universities back in those days.
Worked at universities, yeah. Well, and in fact, my first mainframe class, which was 370 assembler, was at the University of Nebraska, but it was actually run under ZVM. And and I later learned about how the university served up mainframe compute.
Right.
So Yeah, it's, the mainframe community is a very close-knit family.
Yep.
And it seems to be very welcoming of young people. And I have told young people that it's a great place to make a career because 10 years from now, you will be one of the senior people in many shops because people have worked for 30 years and they're going to retire. If you come on as a Java programmer at, pick any big company in the country, you will take 25 years to get that level of seniority that you can get with 10 years on a mainframe. And mainframes aren't going away anytime soon. And in fact, what's cool, because I've been in my job as a Z architect, I've spent all day talking about helping a traditional mainframe ZOS client. How do we bring in containers? How do we do DevOps?
Yep.
How do we do AI? And it's a very modern platform in the software as well as the hardware, but people think of it as an old dinosaur.
Yeah.
And it's like, if I look at the Intel 386 server of the day running OS2 Warp server or Novell NetWare or something like that, that's an appropriate comparison, but nobody would say that equals Intel computing today. But a lot of people do that with the mainframe. So I wish I knew more about the specific things, but it doesn't surprise me what you're talking about. And yeah.
Well,
Other
last year
questions?
last year it was free
Go ahead.
because it was all virtual, so it wasn't a question.
And it's interesting because like Share, went from like $1,000 or more down to $199 for this Share last fall. And of course, you got a lot more people that could attend. Now, it wasn't in person and you didn't get all the networking, but it was kind of nice. And I think that more of these groups will do a hybrid where there's an in-person and an online option in the future. I hope that stays that way.
I haven't seen any hybrid yet. Although Red Hat's he's got a conference coming up free, I think next week.
They do.
Yeah.
They do. And I know I've talked to the Share leaders, and IBM has, now it's called TechU or Tech University, Technical University.
Yeah.
And I think that what I'm hearing is that people actually like this hybrid approach. And yes, you will lose some in-person attendance if you can sign up online for like half the price or less.
Yeah.
But there's still value to being at an in-person meeting or conference or something. And it will be interesting to see, say, a year or two from now, will they be hybrid conferences? Will they be online only, or will they have, in-person only? And, I won't guess, but I think there's good odds that you'll see more hybrid conferences than you used to.
I totally agree.
Yeah.
This is Ed. Sorry I got here a little bit late, but I wanted to ask a specific question, but you were talking when I came in and I didn't get the number. How many total Linux images can be run at the same time? It's in the thousands.
Okay. It's in the thousands. So there was, and this was, so, if this is the Z15 hardware that LinuxOne runs on, I think this was back in a Z10, and then we called it the Z196 days. So it's years back. But somebody bragged that they had started 8,000 virtual Linux guests on a single mainframe running like Hello World. And so, yes, it's possible, but like, why would anybody want to run 8,000 copies of Hello World? But yes, I mean, so these trusted, execution environment that I talked about with the protected, that ultravisor and the protection, you can see here saying that I could run thousands of those on a fully loaded 190 core mainframe with, 40 terabytes of memory. It is true. If I'm running OpenShift containers, I could run hundreds of those. I could run hundreds of Linux guests or VMs in a middle-sized mainframe system. And yet, if I'm running Oracle and I'm throwing boatload, throwing 40 processors at it and 15, 16 terabytes of memory, I'm going to run out of 190 cores and 40 terabytes pretty fast. If I have little small containers, I could do hundreds or thousands of them. Yes. And
right. Well,
yeah, go ahead.
No, it was just kind of comparing and contrasting, the scalability of that compared to that tiny little tiny Linux kernel that's running on the planet Mars right now.
Yes. Isn't
No, I
that
mean,
interesting?
yeah, just a weird, comparison.
Well, and obviously, here's something that's really interesting. So my introduction to the mainframe was in 1998, selling Domino on the mainframe. Talk about a difficult, costly program to run compared to running it on Windows. And IBM AS400 was a phenomenal place to run it. The Unix systems ran it well. But the way that the mainframe and what was OS/390 at the time would not allow memory leaks, but they would, append the program and tell you, here's this thing is broken here. Lotus had memory leaks that have been out there for years, and I know from the development team for OS/390, they found and fixed memory leaks in Lotus Domino that were 2 and 3 years ahead of Windows. And we made, when IBM really got involved in Linux in the early 2000s, we did a lot of we know how to build operating systems for commercial systems, big ones. And we shared some of that, and we improved the scheduler and the IO routines. And Linux became a much more performant, scalable operating system from the open source contributions that IBM developers made. And so to your point, yes, there's that little tiny Linux kernel running on Mars, which is amazing. These are not little tiny Linux kernels. These are more enterprise class Linux kernels that have, more things that you would run mission critical workloads on. But yeah, it's still a pretty slim operating system compared to, other things. And in fact, Core OS, which is a slimmed down version of RHEL, which is the Linux OS for OpenShift, is even a skinnier Linux that it uses as it's running a node. And Linux is so flexible. It's fun to see all the things you can do with it. And, I have enjoyed working with Linux on Power, which I've worked on, and Linux on Z. These are great pieces of hardware for businesses, and they do things, and yet there's absolutely a role for x86 Linux computing. And that will always have, I think, the number of servers by far running over this. I will tell you, I have a client that is looking to consolidate hundreds, if not a couple thousand of Linux images running as VMware VMs into one of these big Linux, or a couple of these big Linux mainframes, because they think they can save a lot of money. And it's their idea coming to IBM saying, we want to do this, versus IBM selling them on that. They have experience doing it. And, I'll say I'm from Missouri, show me, but I'm actually pretty confident that we'll achieve what they want to do, in the next year or two. And so it is a valid Linux server. Yes, it's mainframe technology, but that means I get the compression and the encryption and the scalability. And in fact, in that single system image, what's cool is if I want to move a workload from one LPAR to the other, but in fact, they're on the same system, I can dynamically, as LPAR A is not needing 10 cores of processing, but maybe 1, those other 9 can dynamically flow to LPAR B where those workloads are at, and it can scale up. And I don't have to spend a single penny on extra hardware. And the mainframes have built-in spare processors. So if one goes bad, I have one, they come online, they call in IBM and say, I've got a bad processor, come out and replace it. The memory that runs in a mainframe uses, we call it RAID, but it's RAID for memory. So there's extra memory DIMMs doing parity checking, just like RAID does for disk. And so there's far more memory errors that we can tolerate and not go down and not corrupt data. And so, those are things that cost money, and these are not the cheapest pieces of hardware on the planet, but they're things that provide business value for critical workloads. And that's kind of how and when you get into running Linux here versus Linux on an x86 server, which is also a good piece of hardware. So
yeah, that was a
fun.
really long answer to a quick little observation, but I really wanted to ask another question. I've been using Unix really on the with mainframes back in the early 90s. In
Yeah, I was
Livonia,
talking about
Michigan.
that early on. Yeah, the
Yeah,
Irish commands.
and they had this little company, was called Liaison Systems, and they one of the things they did was they printed all the paychecks for every Ford employee in the world, designed to
Wow.
be on every employee's desk by 7 a.m. Friday, every Friday.
Wow.
They had like giant laser printers that spit paper out so fast it would kill you. Anyway,
Mhm.
they had a dual banger. I don't know what brand IBM it was, but it was my job to connect SCO Unix running on these little beige boxes that we had, right, to this mainframe.
Yeah.
And the thing that got me was, I didn't know anything at all about mainframes. All I found out was, oh, they have like 3270 terminals and are going into terminal concentrators and multiplexing on these giant thick cables and
Yeah.
all of that stuff was going out. It was all EBCDIC, right? And
Yeah.
so like the first thing I had to do was write a little, bash process to, basically take the EBCDIC, turn it to ASCII, and then when it went the other way, I had to turn it from ASCII back to EBCDIC or whatever, right?
Yeah.
So well, I'm kind of confused about all this stuff. I mean, supposedly the ZOS can run all that old COBOL code that we were running back then without change. How is that
It can.
possible if it's like running Linux? And I mean, where's the ASCII and the EBCDIC? What's all that? What's
Okay.
happening there?
Good question. So, what was legacy MDS and became OS 390 and is now ZOS? Those core programs are still EBCDIC. The Unix system services part of ZOS and of OS 390, which is it uses a Linux file system, it uses Linux permission bits, it does mainly C. That is an ASCII-based environment. Now, FTP gets tricky sometimes of, am I using the USS FTP or the ZOS legacy FTP? And am I sending it text or binary? I will tell you, Linux runs as an ASCII environment on all these systems that I'm showing right now. And so EBCDIC is still there for the older mainframe assembler programs, COBOL programs. But like if I'm running our WebSphere Java server on ZOS, I'm actually running it as an ASCII program on the Linux side, on the Unix side, not the Linux side, but the Unix side. I also have WebSphere that will actually run in like RHEL Linux on one of these systems here. And it's interesting because ZVM, the hypervisor that most people use, is an EBCDIC environment that hosts Linux kernels and OSs and VMs that are ASCII environments. And so somehow that works under the covers. And it is interesting where those lines are and how they cross. But yes, there are companies that wrote code 40 years ago that they're still running COBOL code against IMS databases or vSAN files. And that same machine can take and have an LPAR that is defined as a, bare metal Linux LPAR, or run ZVM, and then I can run Linux guest, virtualized inside that. And, one of the things that I will say, ZVM being a real mainframe operating system and a fully software-defined operating system is far more efficient and performant than KVM or VMware, although VMware is far better today than it was 10, 15 years ago. And so, that's one of the reasons these things perform so well. So there's probably more history. By the way, there are a ton of really good YouTube videos. If you get interested in this and want to learn about it, you can go out and watch videos and learn for hours and hours and hours. And I encourage you to do that. But I hope that's at least a little bit of an answer for how the ASCII EBCDIC and the Unix system services and all that plays, because it's still there today. And I have clients that sign in every day to their bash shell in ZOS, and they do shell commands. If you look at Red Hat Linux, most things you would have no clue you're running on a mainframe because it's Red Hat Linux. And all the shells are there, the tools are there. you know, it's a Linux experience. Under the covers, yes, it's different. And yet your typical Linux admin is also usually not the VMware admin. And so in the same way, the Linux admin on Z would not be the ZVM admin. And in fact, my recommendation is you have one Linux team that does Intel, Power, and Z. And they're the Linux team because their skills are portable. And that's not something mainframes could say 20 years ago. They were not portable skills at all. So I hope that helps.
Yeah, it did. Thanks. I guess it's just magic.
Yeah, it is really cool stuff if you like technology. I don't get to play in it as much as I like as an architect, but it is fun stuff when I get a chance to go back. And this forced me to dig it deeper into the hardware, so that it was really fun getting ready for tonight. Any other questions or comments?
So can you put your mail address up again, or are you going to put the
Yeah,
slide
I was actually
someplace?
going there. So here's my email address, and I will, to the people that arranged for me to be here tonight. I've got a PDF version of this file. I may not get it out to tomorrow, but I will get it out. They can pass it out to the users group, and there's nothing confidential in here. And you're free to share it. And what's nice is at the back, I had all those links with places to go learn more. And so there's, plus there's that community cloud where you can get your own Linux on mainframe guest, and you can play with it and experiment with it. There's some things that have guided trials, and, there's like Linux for Dummies books that relate to mainframe that are out there. And so you can certainly find a lot of things to look at. By the way, for any of you that have worked with IBM much, there are these things called Red Books, which are actually some of the best technical documentation that IBM ever creates. And there are Red Books out there on Linux on Z that if you want to do some technical reading and learn more about it, I would, I think it's either IBM or www.redbooks.ibm.com or something like that. But you do a search, you'll find it quickly when you type IBM Red Books. And I strongly encourage you to go exploring there as well to learn more. So I really enjoyed the time and the conversation, and I hope you guys all have a good evening. And like I said, if you email me, please use the user group acronym so I know it's related to tonight. It may take me a day or two to reply, but I'll try to flag them and make sure that I get back to you with answers and so forth. So appreciate the conversation, and thank you.
I got another question if I can fit one in.
Yeah, go ahead.
You were talking a lot about ZVM, which seems to be the preferred hypervisor. But some of the older documentation on LinuxOne seemed to refer to KVM and other hypervisors. And it almost seemed in some of that earlier documentation, like from 3-4 years ago, that it would be one was better for running SUSE, another one better for running Red Hat, another one better for running Ubuntu. Is it now all just they all run the same, or?
Oh, that's an interesting question, and I'll give you my opinion of that, okay?
Yeah.
First of all, if you are either a cloud provider and you want to run free software, KVM is nice because it's free, and KVM is the same just like Linux is, whether it's on an Intel server or the mainframe or whatever. KVM was also very popular in Europe, and that's where SLES came from. And in fact, SLES got a big head start on Red Hat for Linux on the mainframe. And then for a while, Red Hat didn't want to run on SLES's KVM, and there were some food fights and so forth. So here's kind of my bottom line. I think that ZVM is a more mature hypervisor for the mainframe, and obviously it only runs there. So I'm not making a comparison like KVM versus VMware, Power VS, VM, things like that. This is purely a ZVM, KVM discussion. ZVM is more powerful. It is a mainframe operating system, which means there is the learning curve and the skills presence and all that you need those skills to really leverage it. If I wanted to bring, distributed systems people in and stand up mainframes and they know KVM, that might be a great alternative because of the skills issue to do KVM on the mainframe. And in fact, the food fight between the Linux distros was bad enough for a while that IBM had an official distro of KVM that then, you know, like Red Hat could use and SLUG could use, and IBM did the support. And then that went away, and I forget I think everybody's shipping a KVM with their Linux now. And it's like you use Red Hats for RHEL and SUSE's for SLUG and so forth. But I will admit that that's something that it's been a couple of years since I've heard about, but I remember the food fights, IBM trying to come up with an answer. And so KVM is viable. You know, my take is if I've got a customer that wants to run, you know, 100, 200, 300 mainframe cores, which is hundreds of Intel cores worth of Linux workload, I would probably do ZVM if I could, but I wouldn't be afraid of KVM if I couldn't. And then what's interesting is OpenShift, in theory, you know, you don't do as much work with the hypervisor level. You really need to stand it up basically, and OpenShift becomes the focus, you know, with its core OS and its tools and the nodes and the clusters and all that. So right today, it only runs on ZVM, but I'm betting you don't need the heavy ZVM skills to run OpenShift that you might want to run with native Linux. That's, again, my opinion and guess, but I bet I'm kind of true. I'm right on that. And, you know, so we fully support both, and KVM is getting updates. And in fact, if any of you happen to be members of Share, the slides that had all the little circles, like, you know, kind of halfway down, let me find one, like, looks like this one has it. These circles here, these are from the latest Share. And there were sessions specific to KVM that you could go look at. And if not, you could look at, you know, redhat.com, SUSE.com, and look on KVM and the mainframe, and you could learn more about it there as well. So it's worth looking into, no doubt.
Neat.
Yeah.
And you can mix and match.
I have a comment.
You can mix and match. Yeah, go ahead.
Yeah, going back, I'm a little older than most people here. And I remember VM, it's about 30 years older than any of the other hypervisors you've talked about or can mention.
It is.
It started way back in the early 70s, late 60s, early 70s.
Yeah, 67.
67, okay, so I'm close. And it only runs, as you mentioned, it only runs on IBM chips.
Right.
I'm sure.
Not totally true.
Totally true.
Not totally true. I learned last year that or actually year before, there's something called Hercules, which is it doesn't emulate new IBM hardware, but it emulates old IBM hardware. So you can run the old VM on it, and it's all software emulated.
It's all software emulated on Intel, and I don't know that it's legal to run, because I know that it's legal to run Hercules. There are some IBM operating systems that the license in them today says they have to run on approved hardware.
Well, that's why I said it has to be an old version of VM.
It has to be an old version. And I will tell you too, there's actually something that the current name is called ZD&T.
Yeah.
And it is a Z emulator for Intel servers that we have for like ISVs that want to have the ability to run ZOS or ZVM and Linux on Z. You cannot run it for development, but you can, you cannot use it in production legally, but you can use it for development and testing and like support. And that does run on Intel servers. And so, you know, but it is a very special use case. And of course, IBM doesn't want that getting out where you can run mainframe workloads on Intel because that would kill our hardware business in many cases. So you're both kind of right in that regard, but generally it runs only on mainframe hardware, and I would agree with that. Certainly the new versions. Okay.
My point, my point was that since the XV or ZVM, the old VM, and IBM hardware were so tightly together, the capability of extending hardware to provide capabilities for the virtual machine hypervisor to work better is one of the reasons that VM is so performant and it works so well. And
You're right.
almost everything else because it had the ability to more closely match capabilities between hardware and hypervisor.
Yes.
So I'll make two comments. And this was actually in a discussion today. When we're sitting down to build a new mainframe, and that usually is like a 5-year process, we start with the hardware designers, the operating systems, all the middleware and databases, the compilers, the DS8 storage, the TS7700 tape. Now Red Hat is probably coming into that since they're part of IBM. And we design this as an integrated stack, to your point. And it's known that, hey, we're going to do this. We need to do this in the hardware and this in the operating system, and DB2 needs to do this, and the DS8 needs to do this in disk. And it's all tightly connected. And it's the same power like Apple has with the iPhone. They can exploit things and build things really better than most Android phones because they own the whole stack. And they can all talk to each other throughout development. And so Prism, which is the real hardware virtualization in firmware that makes the mainframe what it is tightly connected to everything. Now, the interesting thing is, if you know anything about Power VM, which in many ways is kind of the power hardware virtualization layer, we, in many cases, in multiple ways, would take people from Poughkeepsie and send them to Austin or Rochester and say, no, you guys built Parallel Sysplex, you built Prism, we need you to take that, and how would you do that on a power-based system that runs, back in the day, OS 400 and AIX. And then there's been things in hardware chip design where the power chips coming from a RISC architecture built some really cool things with out-of-order execution and pipelining and things like that have been put into the mainframe hardware chip architecture, and they've shared hardware designs, and they're now a single team, even though they build 2 chips that run 2 sets of operating systems. And so, there's value in that tightly coupled, and that is how you get performance, you get security. The mainframe security in like ZOS comes because I have hardware, I have storage, protect keys and memory, I have it in ZOS, I have this whole RACF, it's called SAF, the Security Access Facility, I think is the acronym. And it's so woven into every part of the stack that it's much easier to really lock that down and enforce it than anything that is more of a bolt-on or was added on 20 years later. And it does make mainframes really interesting in that regard. And so Linux is able to pick up on some of that, especially because of the way ZVM does pick up on all that and then exposes that to Linux machines. So I'll tell you, it's a fun place to be. It's growing, it's vibrant. Another thing actually that I forgot to mention, since Java is a popular Linux workload, it was in the Z14, and it's very unfortunate because you would hear a presenter talk about something called pauseless garbage collection. And if you know anything about Java, when it goes into garbage collection mode, everything freezes and it can be ugly and it's bad. And you have to try to design, well, how do I prevent that? There is hardware in the Z14 and the Z15 that is able to some of it happens under the covers, dynamically. I don't know how it works. And you have to sometimes do garbage collection, but it takes far less time and you don't do it as often. And so pauseless is actually 2 words with a hyphen, pause dash less often. But the trouble is you hear people say pauseless and you think there's no more pauses, and in fact, that would be cool. But there's hardware in that Java workloads really benefit from and run faster because they're not doing garbage collection as often and as inefficiently. And that's another example of how really taking hardware, operating systems, middleware, and linking them together and really leveraging each other to get a better experience. And there's obviously partnership with Intel and Dell and VMware, which is Dell and other things, but it's not the same as one company that owns the stack. And so it's an interesting observation you make. I have gone way over 30 minutes, and I'm happy to keep talking. I don't want to keep you guys late, but this is a very enjoyable discussion, and I hope you're enjoying it too.
you're okay. I have another sort of comment question.
Okay.
And in the mainframe architecture, there were I/O processors in the hardware, and there were multiple of them, many of them. Now, the x86 architecture has the concept, but I believe they're limited to maybe one per core of those processors, whereas the mainframe had many, like the old big mainframe cyber systems that CDC made long ago.
Yeah.
But now those in the old systems, those were only used for I/O to disks. Are those processors now used not only to disk, but to other things like network as well, to offload some to get better performance?
Yeah, so that's a really good question. And I'll tell you, by the way, if you go find the red book on like the Z15 technical overview, you can find a multi-100-page red book that talks about much more details of the hardware than I put in here, because I thought I was going to talk for 30 minutes, and obviously I blew that. But again, I've really enjoyed this, and I'm happy to keep going. So in the hardware, there is something called a SAP, or a System Assist Processor. And you don't pay for them. They're part of the system when you buy them. And there will be 2, 3, 5, several. And they are I/O processors that do not run any operating system. There's no software cost, but they offload I/O. And one of the ways that ZOS is able to run, and ZVM both can run so many parallel workloads, is that when you make an I/O call, you tell the program to wait, and you may pull it off of the dispatch, and because you've got all kinds of programs waiting to dispatch. You go to the System Assist Processor, which goes out into the I/O channel, and I'm going to talk about more processors in that channel in a minute. It comes back, it's ready, it signals ZOS, and it says, hey, I'm ready, here's the I/O, get that dispatch back in the system so I can take the I/O and go. And there's no CPU cost. It's not spinning on a lock and wasting cycles and all that. It actually keeps running. That's another way it runs at 90+% busy, because it's able to do real work, and yet it happens fast enough that you don't feel like I'm waiting for half a minute to get an I/O read. There's not only the SAPs in the mainframe, KEC itself, but then when you go to an I/O adapter, and the mainframe technology today is the legacy, count key disk uses something called FICON, which is very similar to fiber channel. Those same adapters, which are called FICON Express adapters, can also run the fiber channel protocol, and they can run SCSI. In fact, there was some comments about SCSI somewhere in here. And on those adapters, there are multiple power processors. Now, if you remember back in the early days of power, there was something called the Power PC, and in fact, that ran Apple hardware, PCs for a while, and IBM did some things with it. And you can't really buy servers with Power PCs anymore, but we still make them. And, like a dual frame LT1 might have well over 100 power chips in them running I/O. There's usually 2 or more on a disk, on an I/O adapter. And then the network adapter, which we call an OSA card, or an open systems adapter, also has power chips on there. And so you might have a mainframe with 20 Linux cores and 150 other processors running security, running I/O, doing parity checks and resiliency and reliability, things like that. So yes, they're very much still there, and they're another reason why I/O is so strong in the mainframe, because I might have 100+ processors, full-blown, processors doing nothing but I/O. Great question.
Thank you.
You're welcome.
So kind of looking at that same question a little bit sideways, or your answer a little bit sideways. So the actual CPU, if you will, on the mainframe, That's not a power chip?
It's not. It's a mainframe architecture chip. And in fact, there was something, I forget the name, 10 years ago, where there was this research and thought about IBM's going to converge to a single chip, and it will run the Intel instruction set, the power instruction set, and the Z instruction set. And they actually designed it in the lab. The trouble was that the Z workload ran like a dog, because the way the Z architecture works, the cache and things like that are different enough that converged design it was more of a RISC architecture, and so it ran AIX pretty well. And Intel, I'm guessing it was a fast enough chip, whatever emulation it was doing, it could work. But the Z workloads didn't work, so they gave up on that. But it is a dedicated chip that only runs in a mainframe. That are like the cores that are here. I call them general purpose engines in a ZOS world, or they're called IFLs. Well, on a Linux machine, it's integrated facility for Linux. On an actual chip, it's the exact same hardware. And what we do is put firmware around it to say, because we sell it to you for a small percentage of the mainframe core, the engine, we will not let it run ZOS. It will only run Linux or a Linux hypervisor. Because the competition for these machines are Intel machines. And if we come in 50 times more expensive, it doesn't matter how great a machine it is, nobody would buy it. These have to be price competitive, or you have to need like the encryption and things, or these, trusted execution environments so much that the business value justifies the higher hardware cost. And so that's the idea. And in fact, we used to have our own fabrication plants, and we made our own chips. We got out of that business years ago. Right now, IBM Systems is using Samsung as our fabricator. We do all the chip design. We actually announced a partnership recently with Intel for chip packaging, where we're going to collaborate in research. But we have Samsung actually build the chips, and then we assemble all the machines. And for those of you that are interested in chip architecture, go do public reading, and I know more than I can tell you, but there's some interesting reading. There's a new research facility by IBM in Albany, New York, and it's kind of a joint project with the state of New York and IBM. I think these used to be state of New York data centers that we bought and so forth, but we're doing research on chip design specific to AI acceleration. And I was out there today looking at the website, and so there's some really interesting hardware that you're going to see come out of IBM in the future that is coming out of that research site. And as I said, there are some things that are public and you can read about today. I will say in general, when you see a new power system like the Power 10 servers that, we've like talked about at Hot Chips, and so you can find presentations on the chip architecture, and we will be shipping servers at some point. I don't remember the dates. There's always a mainframe refresh every 24 to 30 months. And, I would expect next year you'll probably see a Z Next. I don't know if it's Z16 or what they'll call it. It'll have a new chip in it with new technologies. And so if you like this stuff, when those systems come out, go start to do the reading, find the technical overview, red books, and so forth. And you can learn about what we're doing to innovate in hardware design and chip design, because it is still a core focus of IBM. And because I love hardware, it's really fun to go learn about how that works. And I've actually had the chance to talk with IBM fellows and distinguished engineers who build this stuff, and they can go way deeper than I can understand. But those are really interesting discussions when I get to do them up in Poughkeepsie. So, I could do a whole session just on mainframe hardware, but I really wanted to focus more on Linux. And so I wanted you to know there are things that Linux supports that are mainframe unique, and there's things where Linux is Linux. And it's fun as to how these come together. So I'll stop there on that answer.
Well, kind of following up on that, this whole 5th anniversary of LinuxOne, it almost sounds like that's the thrust of LinuxOne, is kind of this extra integration of Linux with the mainframe architecture?
You know, it really is. And I don't know, I think I made this comment really early. There are a lot of people who think the mainframe is an outdated, antiquated, clunky system and slow and expensive and all that. And yes, the mainframe is more expensive than other platforms. But if you look at what the cost is today versus 20, 30 years ago, it's night and day difference. And if you look at a cost per transaction or this or that, it's for heavy workloads, it is really the lowest cost platform. If for light workloads, it's not, unless you put a whole bunch on. But you know, we are very proud of the 20-year history of Linux on the mainframe. And I remember the very first time in an IBM meeting that people were talking about Linux coming out of the Skunkworks project, and about a year later, ZVM had been announced as it was being end of service and it was going away. Someone figured out that VM was a hypervisor that would be really good for Linux. VM was actually built for IBM MVS developers because it could virtualize MVS, and it cut down on the cost of shared hardware and things to write MVS and things like that. That's where it originally came from. And then it became a product in CMS apps and profs, for those of you that may have ever used that. And so Linux gave ZVM life. And in many ways, Linux kick-started the mainframe. Today, Linux is about 30 to 35% of the total MIPS that IBM has shipped worldwide. You know, if you look at how we're selling ZOS capacity versus Linux capacity, it's almost 50-50. And I don't have those charts with me, but you know, I'm not sharing private confidential information. This is, and I would want to verify the charts. I know I'm close enough for grenades, but if you want the real numbers, but they are publicly available. And so Linux has really brought growth to the mainframe platform, even though the traditional mainframe workload is growing. And in fact, if you listen to IBM's earnings announcement on Tuesday this week, I think it was, you know, the mainframe revenue grew 49% year to year because of all the things with the craziness of GameStop trading and stimulus payments. And, you know, there are companies that have been buying capacity like crazy because the demands on these core systems is heavier than it's ever been in their history. And so they're buying mainframe capacity to do it. And, you know, with the mainframe, you can add engines dynamically in and double or triple the capacity. I have a company that I won't say the name, but they're one of the big brokerage houses that all of you would know the name if I told them. They grow their mainframe 5 times in capacity at market open every day of the week. And an hour later, they're back down and they take off that 5x growth. And the mainframe can do that dynamically. You don't have to re-IPL or restart, reboot. ZOS handles it. You know, Prism sees it. It says, okay, you need more. ZOS says, oh, I got 20 more processors. Go. And it's amazing how it can do that. And Linux can scale like that too on the mainframe, partially because of ZVM and partially because the hardware can scale vertically. So it is really neat stuff.
And the significance of that is the licensing fees, like Oracle charging you per core? Or?
Yes. So Oracle on an x86 charges you a 0.5 license per Intel core, and they charge you a 1.0 core on Power or Z. But, you know, we have clients that we've seen them go from like 400 or 500 cores to like 110 or 120. And even if it's a 2-to-1 Intel to Z ratio, at the price of expensive commercial software, and I'm not picking only on Oracle because IBM has expensive commercial software too, but you can easily more than pay for the cost of the hardware and save a lot of money because of core consolidation. You know, the fact that they run hotter, they run much faster, and here's another thing that's interesting, and I don't think I can't find it quickly, and since I'm screen sharing, I don't want to go diving. but we many times double the size of the cache in like level 3. I have 4 levels of cache, and there are, I want to say, tens, if not hundreds of megabytes of cache on, you know, a pair of mainframe cores, because the level 3 and the level 4 caches are shared usually across multiple cores. There's like, I want to say 128 kilobytes of data cache and instruction cache in level 1 cache that is right on the chip. And that is significantly larger for level 2 cache, which is shared, I think, across 2 cores on the same chip. And that's one of the reasons the mainframes are so fast, because it's far less often you go out to memory, you know, which is many, many more cycles than to go even to level 4 cache. But certainly if I can go to level 2 cache, level 3 cache, and if the pipelining anticipates out of order execution, and there's a lot of technology there, the cache on these machines is incredible. And when you look at, you know, how many, you know, I want to say they're getting up 12 billion transistors or more on a chip for the processing chips. You know, miles and miles of copper wiring, and how you put copper in, you know, 7 layers of silicon. Or the chips are engineering marvels, and by the way, Intel chips are too. But it is amazing what goes into a single mainframe chip. That is, the actual chip is less than an inch square. You know, and in fact, we give them away at briefings. We give away chips that are, you know, bad and failed testing, and so they're worthless, but they're cool mementos to give out to people. And so that's another interesting thing. If you like chip design, you should go read about the mainframe chip architecture, because there's some really cool stuff in there.
Nice. Different question. Since you said, you mentioned, you know, you were going to concentrate more on the Linux, the software side here. I guess for Amazon, they have, I believe they call it Amazon Linux, and the idea is anytime you know, rather than worrying about keeping your Red Hat patched or whatever, you just go out, pull Amazon Linux, and it's a absolutely most recently patched and ready to go version. So is there an equivalent? Is there an IBM Linux that's the preferred? You always keep it hot and ready to go for all of us, or?
So I'll say it depends. From a hardware view, we want to be neutral, and so there are more than these 3 distros, but we, from a hardware view, equally support Red Hat, SUSE, and Ubuntu. Now, you know, since buying Red Hat, there's probably some favoritism towards Red Hat, you know, in the anybody who doesn't sell hardware, but the pure hardware sellers and the hardware brand still supports all 3. You know, you said Amazon, so now you're talking about, you know, infrastructure as a service. Mm-hmm. And Amazon provides the Linux virtual machine. You know, they own the Linux kernel, they patch it, they keep it secure. And so IBM's answer to that would be the IBM Cloud, which has infrastructure as a service offerings. You know, in fact, it is something that we don't have the number of clients that Amazon does, although I've heard that you would be surprised at the number of businesses that are picking, you know, business reasons or security reasons to pick the IBM Cloud over Amazon or Google or Microsoft. So we have that. We would do it that way. Now, there are some things where there's like a, you know, IBM services will manage on-premise environments. And in theory, you could contract, I think there are ways to contract with IBM and or Red Hat to in essence provide, you know, an on-prem copy of Linux that is constantly updated and patched, and you know, you get it as a service, except it's on-prem and not in the cloud. You know, the challenge is that, you know, where Linux is dynamically patchable, you're good, but if I need to reboot it, you know, then obviously you still have to do that, and Amazon does that. But you know, there are some clients that don't want anybody doing that work. They really want to do it themselves. And there's others that really want to get out of that business and say Amazon, IBM, Google, whoever, you take care of that for me. Just give me Linux systems. Many times they're t-shirt sizes, small, medium, large, extra large, and you get cores and memory and, disk, and it's cookie cutter. But, for things that you do over and over hundreds of times a month, that's a nice, easy way to do it. You need 10 larges and 5 mediums, and I want them in an hour. And you click, they already have your credit card or whatever, they bill you once a month and you're done. So it's interesting. And I didn't talk much, but I told you that blockchain, the IBM commercial blockchain in the IBM cloud runs on a LinuxOne machine. We also have, they're called crypto express adapters that store master encryption keys. They are tamper-proof in every way possible: radiation, temperature, disassembly, movement, vibration, and they are verified. In fact, we sell those on power systems, mainframes, and Intel boxes, but it's mainly I and Z that use them heavily. But we've set up a service where you can bring your own encryption keys, your master keys, to the IBM cloud. And the way those HSMs are set up, it is impossible for any IBMer, no matter the court order or whatever, to get in and break in and read that encryption key and decrypt data of that client. Where if you go to the other clouds, it's like, we promise we won't, but in fact, they can't technically prove that they can't get to it. And so that's something that IBM sells why you run on the IBM cloud. But it's because of the mainframe, cryptographic adapter with, cryptographic processors that are, I think, dedicated processors. I don't think they're Power or Intel or whatever, that are part of the reason of the security of this box. Another thing that's cool, I said that I can encrypt data, in flight, at rest, no latency, no CPU cost, and that's on the chip. I had a chart about the CPAC-F picture. Is that? No, it's farther down. I think it's this one. You have to have a key in memory that's doing that encryption. Well, those keys are actually wrappered keys with master keys that are protected in tamper-proof environment. And so those keys are encrypted that you encrypt with. And in a memory dump, you will not be able to dump the encryption key to unlock the data, which is unique to the mainframe. We call them protected keys. And it's another way of the way you can keep the data private. Linux supports all that. And that's mainframe technology that was built for mainframes a long time ago. Linux is able to pick it up. So some of it is Linux. We design for Linux in these chips, and we add instructions and things that Linux or the hypervisors need. In other cases, Linux, we've worked with it, and it can just use this hardware because we've written the device drivers or the API calls or whatever. And I'll tell you, this is amazing technology of the ability to encrypt huge amounts of data seamlessly. I've not seen this anywhere else yet at scale that a mainframe can do. And every single core has its own dedicated cryptographic accelerator on part of this is the chip layout of a Z15 core. So, you know what? I actually have to do 2 pieces of work tonight that I promised my manager. And so I'm going to shut this off. I've really enjoyed the conversation. You guys have my email address. You'll have the charts tomorrow. At least I'll try to get them to the facilitators. And I thank you very much for your interest. And I hope this was enjoyable to you. And I wish you all the very, very best. So thank you.
Thank you, DeWayne. I really enjoyed it.
You're welcome. So I'm going to drop. You guys, continue your meeting wherever you have. And but again, thank you, and go Cardinals. Okay.
This is really great. Thank you, DeWayne.
Oh, you are welcome. I appreciate the opportunity. We'll see you.
Bye.
Bye-bye.
Yeah. Hey, Gary.
Yes.
We had a presentation on IBM Unix 1 3 to 5 years ago. You remember that? They were talking about these mainframes.
Well, I really don't. In the back of my head, I remember talking about it, but I don't actually remember the presentation.
Well, I don't remember a whole lot of detail. You know, that's just not realistic. But one of the things that struck me at the time was, you know, when I think of a mainframe, I'm thinking of old IBM 360s that we had in a number of places I worked. And, you know, they were really dinosaurs. They were. But when we had this presentation here, and I don't remember who made the presentation, but he went through more, he more talked about the hardware. And I remember being really pretty much stunned at everything they had built in there to keep that machine up and running come hell or high water. And I don't remember a lot of detail, but I remember being very impressed because, you know, you'd say, well, what if this breaks? Well, they got two of them over there and they switch in automatically. Well, what if the power supply goes dead? Well, they got an extra one of those that's, you know, hot and running all the time anyway. And, you know, and it was just subject after subject. They were doing it, and I was really impressed. You know, and I assume this is probably better than it was 4 or 5 years ago or 3 years ago whenever we did that presentation. And I can see if I had a large business, you know, if it was at all economically feasible, I would definitely want this equipment because your stuff stays up, you know. And I didn't realize about the IBM cloud that even given a court order, they don't have the ability to get in there and hand off to the government your data. They just physically can't do it. And I'm thinking, gosh, that's a good enough reason to use IBM's cloud. I mean, do you trust Google that much or Amazon that much? Not so much. But I just thought that was a really important point that a lot of people will just miss. You know, if it's like Apple, if they don't have the ability to get in there and break into the system and, you know, give the FBI whatever they want, I think that's a very valuable characteristic for them to have. You know, things being what they are the last couple of years, I don't trust. You know, if you'd asked me 10 years ago, do I trust the FBI? I would have said, hell yes. Today, hell no. You know, all the shenanigans they're pulling, I don't trust them. I wouldn't say hello to them without a lawyer. You know, and but that's very interesting that IBM can't even get into their own hardware. You know, and look at somebody's data, even if they want to, they just can't do it. That's pretty impressive.
If you recall a little bit, Apple can't look into a phone either for the same reasons. Remember that case where the government wanted information from somebody's phone, but they couldn't get it.
Yeah. You either have the password or you did not have the password. And I got a Proton Mail account a couple of months ago. Just, you know, it's based in Switzerland. It comes from CERN. And all the data is encrypted, end-to-end encrypted. When I click on my Proton Mail, when I click send, it tells you, it takes a second or two, depending on how big your thing is. It encrypts it before it ever, they put an encryption process on my computer as part of Proton Mail. So if I send something, it gets encrypted before it ever leaves this box. And it stays encrypted on their system. And, you know, it's encrypted when it goes out. And they have no way of finding which one of those is my accounts because they can't read the data. And when you sign up for an account, they simply don't ask for any identifying information. there's a disclaimer that says pick your password, pick your username. I just use random numbers. And it says don't lose them. Because if you lose them, you just screwed yourself. So we can't help you. You know. And I thought, I like that.
I got to put in a caveat about that Apple thing. I'm reading a book right now called Countdown to Zero Day. It's all about the deep analysis of the Stuxnet worm. And in that book, they talk about the secure enclave on the Apple iPhone. And it turns out that whole thing about, oh, even Apple can't even get into your data, even if the government tells them to. Well, it just turns out that really what's going on is that Apple's just really bad at hacking their own hardware. Problem is, there are other people that are not that bad at it. Nation state actors,